This video will cover everything you pretty much need to know about using your classpad to do linear functions or linear relations. So what we'll do is we'll cover graphing some linear relations, looking at finding or using the calc to find the x and y intercepts, looking at getting the calc to find the gradient, generating tables of values, and also adjusting our screen dimensions. So what we'll do first of all is start with a linear function, 2x plus 3y equals 12. And just imagine I'm asked to find the x and y intercepts for this particular function and sketch it. If I've got my calculator with me, it's going to be really easy. So what we want to do is go to graph and table. That has everything that we need. And we'll just clear out all the old rubbish that might be in there. Alright, so the first way I'm going to graph this is the drag and drop method. Okay, so that's 2x, so I type in my function, that's 2x plus 3y equals 12. Alright, now all I simply do is grab the function only, forgetting that I've got y1 equals there, and just drag and drop it down with my stylus, and that just puts it onto the Cartesian plane. Alright, now if we had to sketch this on a piece of paper, it's not good enough just to look and sort of think, oh yeah, it sort of goes through 4 on the y-axis and 6 on the x-axis. Let's use this thing called analysis and gsolve. Okay, and what we're going to do under gsolve is the xcal and ycal. Okay, so the first thing we're going to do is get an x calculation, and the x calculation we get is in fact the x-intercept. So I want to know when the x-intercept occurs. So let's click on xcal. And what it asks for is a y value. Well, I know that the x-intercept occurs when y is 0, so I type that in. And what the calculator does is it puts up this pink cross, I suppose, on the value of the x-intercept, and also puts it down below here. So I know that the x-intercept of this particular function is 6, 0. Okay, so that's the x-intercept. Now let's use analysis and gsolve again. This time we're going to use a ycal to get a y calculation. The y calculation we want is the intercept that occurs when x is 0. So I hit OK, and it goes straight to the y-intercept, and the y-intercept occurs at 0 and 4. So let's just write that down, 0, 4. So if I wanted to sketch this function on a piece of paper, and this was the calculator section of my exam, this would be really, really easy to do. I've got 2 points now to do that. Okay, now just imagine I'm asked to find the gradient of this particular function. Look, I can use rise over run if I want. So I know I've got a negative gradient here. The run is 6, the rise is 4. Okay, so going across 4 units and down 6. Okay, so if I've got m equals rise over run, I've got m, the run is 6, and the rise, well, in this case it falls negative 4 units. So my gradient is negative 2 on 3. We can also get the calculator to do that by putting this into y equals mx plus c form. That's also pretty easy to do. Let's go to the main menu again, and we haven't been here again, but already. But let's go in there. And what we're going to do is go Action, Advanced, and Solve. The solve function allows us to make anything of this the subject. So I'm going to type in my function 2x plus 3y equals 12. I'm going to solve for y in this case. So I make sure I select y and close my brackets and hit enter. And that's what it does there. It puts it into y equals mx plus c form. So in terms of y equals mx plus c, this function here is the same as y equals negative 2x on 3 plus 4. Now we know, according to y equals mx plus c, that's the y-intercept, and negative 2 on 3 is the gradient. Whatever the coefficient of x is the gradient. We also found the same thing by using rise over run. That's no accident. So that's pretty much a couple of things off my list. Let's go have a look at what we're supposed to do. So this is how I graph relations. So we've done that. Where's review? We've done that. And we've found x and y intercepts using xcal and ycal. We've also found the gradient. Okay. Next, what we'll do is we'll do and generate a table of values. Okay, so let's go back to our other page, and what we'll do is we'll work on this second function, y equals 4x plus 200. To do a table of values, we're going to go back into our graph and table. I'm going to clear this one out, edit and clear all. Interestingly, a function that's inserted or put in like this or drag and dropped, you will not be able to generate a table of values. A table of values will only be able to be generated if you're in y equals mx plus c form. This isn't in y equals mx plus c, therefore it will not generate a table of values for us. So let's clear it. And let's type in our function. Okay. Now notice what I do here is I actually don't type it in with y equals. This is basically the equivalent of y equals here. And watch when I start typing, I just type in 4x, and it basically says y1 equals. So 4x plus 200. Okay, so to graph this function, I'll hit enter. Make sure it's selected and hit this button here. Ooh, it doesn't look like it's graphed, and this is a really common thing that happens. What we can see here is that my function has a fairly steep gradient and a y-intercept that occurs at 200. Positive gradient and y-intercept at 200. And we can see that my y values go up to 4. So what I'm going to have to do is to change my screen domain. One quick way of doing it is zoom and auto. Okay, and what zoom and auto will do is take you to the y-intercept and then adjust the settings around it. It gives us an idea of where the graph actually is. Then I can hit that button there, which is the screen adjustment button, or the changes the dimensions or the axes dimensions. And we've got an x min and a y max of -7 to 7. Let's change the y minimum and make sure it goes all the way down. Well, let's go even further than 0. Let's go down to -10 and hit OK. And that just changes it up so that we can see the y-axis and the x-axis there. Okay, now that still won't tell us what the x-intercept is, so let's make another adjustment. And let's take our x minimum back to -500 for argument's sake. Okay, bit far, but now we can see both the x-intercept and the y-intercept. And now I can again use gsolve, xcal and ycal. The x calculation will give us the x-intercept that occurs at 50, 0. And let's grab the y-intercept while we're at it. So we'll get a y calculation when x is 0. That value is 0, 200. So look, that's just another handy way of being able to sketch a linear function. Now, so that's also adjusting the screen dimensions. Let's just check what else I need to do. Table of values. So that's how we adjust the screen dimensions, and that's been done. Whoop. Review. We're just going to generate a table of values for this. Okay, so let's go back over here. So if we want to generate a table of values, we hit this button here. Okay, and by default, what's been inserted is the x values 1, 2, 3, 4, 5. Just say we want to sketch it over the domain -3 to 3. So what we can do is just simply hit this button here, and it changes the table input. So we'll have our starting value of -3, our end value or our maximum value of 3, and the step says how we go up from -3 to 3. So this will go -3 to -2 to -1 because the step is 1. I could change it to 2, that is go up in 2s or 3s or whatever I wanted, but let's just stick with 1. I hit OK, and we can see that it's just filled in our table of values for us all the way down to 3. So when x is -3, y is 188. Just to show you how the step changes, let's change the step to 0.5. Alright, and you can see the effect of that. It's gone from -3 to -2.5, so we're just basically going up in 0.5 increments or 0.5 increments. So that's the table of values, and that can be handy if you're asked to generate a big list of table of values. So that takes care of that particular option or that particular item now as well, is table of values. So we're pretty much done with that, and that's pretty much all we'll need to be comfortable with doing on the calculator.